Good afternoon, dear colleagues. Can you hear me?
Yes.
My name is Oleg Adorushenko. I have been assigned to conduct the second part of section 2.2 software. And we will wait a bit and then start our work. The first, we can start our work. The first report, our section, an approach to developing a software requirement specification template for Greenfield project using artificial intelligence. Speaker Maxim Navrotsky, yes?
Yes.
Please.
Hello, everyone. Nice to meet you all. I'm Max. So for today's presentation, our topic is the approach, as it was stated before, the development of the software requirement specification template for pretty much new Greenfield projects with utilizing the artificial intelligence. So for the content for today, we're going to focus up on the prerequisites for research and development. Is like, how do we decide to do what we do? And for the second, we're gonna to describe in details the structure, implementation, and approach there. For the third, it's gonna be the explanation of the architecture and how
Maxim, please wait. We cannot see your presentation.
Oh yeah, sorry. 1 second, I forgot to share my screen. Is it better?
Okay.
Okay. Yeah. Thanks. Sorry. Yeah. So, and for the fourth point, we're gonna cover the point of the evaluation of our classification and generation for software requirement, because somehow we need to measure the success rate there, right? And for the fifth and the sixth points, it's results and conclusions there. So that's pretty much it. Let's start from prerequisites here. So it's pretty straightforward for us in our development cycle and research that the cost of fixing the defects on the software is gonna increase significantly, starting like really low numbers during the requirements development phase and reaching the highest possible number after the release of the product or the software product operation stage. This growth is pretty much linear with, but I would mention there, my note here is that the trend there is pretty much, how to say, exponential. So yeah, it's something to bear in mind. So the conclusion here, the earlier you find the defect and fix it, the better, pretty much. And our research decided to cover up the Greenfield projects that are pretty much the blank page for the developers, business analysts, and other stuff of the team to make sure that every single decision there about the technology, stack, architecture is going to be without accommodation to the existing requirements, especially code bases or infrastructures. So it's really important to mention that this specific research that we're covering up is for freshly created projects without inheriting older code base or something like this. So regarding the objective of this work, we have developed an approach for generating requirements for those projects using AI. We have 4 stages. How do we actually do it? We have 2 main parts: classification, and second part is formation for software requirements. That we're utilizing for this the artificial intelligence that's related to the field of the natural language processing. So we're going to cover up those stages step by step, but I will mention that each of stage like briefly. So stage 1 is the pretty much, I will say 80% of the work is there, where we've been trying, how do we process the data? How do we formalize it, structure it? So it's all about receiving information from the client and working towards like the client, when the client working with our business analyst the most. So with stage 2, we formalize the data and to make sure our neural networks can work with them properly. Stage 3 is going to be classification of the requirements to make sure we know that the requirement either functional or non-functional. And for the stage 4, we're going to finally generate those requirements based on our previous classification prior to standard ISO 29148. Yeah, so as you may see, there's the structure. 4 stages, each one has sub-stages that we're going to step by step. So for stage 1, this is the stage when the client and business analyst communicates the most. We decided to do this with the approach of creating some sort of universal questionnaire that we can provide. I'm sorry, 1 second. That we can provide to the client to make sure the client can also answer them. Those questionnaire, as I will describe later a bit, includes open and closed questions to make sure we can access the highest accuracy in the possibilities of the client. Also, it's important to know that business analyst here is to formalize all the provided answers there to make sure that our neural network provides the best result there. So our questionnaire, a few points about the questionnaire is that in the future, we want to make sure it's standardized for like many clients, but currently in our approach, and I would say the first iteration, our questionnaire is designed for experiment and is not standardized. So it's important to know that development of those universal questionnaire could be a separate task. And as I mentioned before, the questionnaire includes closed and open-ended questions. Whether the closed questions provide clear, unambiguous answer that could help us with the data analysis, and open-ended questions are, I would say, pretty much supportive ones that helps client to specify something, some points or stages that are not included in closed questions. So that's pretty much it. So it's important what I want to, in conclusion, I want to mention that during the development of the questionnaire, it's important to consider the project specifics like industry, end users, and so on. So moving to the stage 2, the data formalization. Important to know here, and what I want to know specifically for myself is that business analyst there formalizes and analyzes what client filled up on those questionnaire, and just in case the client sometimes misses the point of the questions, business analyst helps the client or fills some points for himself to make sure he knows the specifics and everything's kind of answered there. So afterwards, we can move to stage 3, where pretty much all the work being done, especially for classification part. We train network there from the sub-stage 3 and 1. We're for neural network training. We'll cover it up in a few slides afterwards, so no worries. It's not that hard. I would say, just to cover up, it's not the it's not the training by like standard. It's just probably the fine-tuning for ourselves, but we'll cover up later, no worries. So after we generalized and formalized all the requirements there, we can pass up our neural network that classifies them and tells us whether the requirements that we received either functional or non-functional. Of course, it's really important to mention there that some of the requirements could be hybrid, and we'll cover those cases later. There's pretty much interesting results there. Yeah, so for the stage 4, after we classified whether the requirement there is functional or not, we finally going to pass it up to the neural network that, based on our classification, can generate a proper requirement that will state the most details and specifics for the business analyst to utilize later. So stage 4 kind of is the final result of our work. That's it. Yeah, so moving on, we have architecture and informational data flows. So important to know that the classification that comes prior to generation of the requirements could go not only in a subsequent way, but in a parallel one. But for our case, it's really important to know to which category are we classifying like our requirements there. So for each neural network, it's really, how to say, basic stuff that we have like 2 separate databases that we have been using for fine-tuning them, and the 2 neural networks there. So that's the thing how we approached it. So moving on, we have the evaluation of our classification and generation, right? So somehow to know whether it was successful or not, we need some metrics to measure how it was, whether it was right or not, right? So it's what I want to state that for our classification requirements model, we've been using BERT. BERT is pretty much pre-trained model, and we've been fine-tuning it to our data set, which we'll cover up, I believe, in the next slide there. So, yep. And for requirements model, we have been using the GPT-2, which ability to generate contextually appropriate text made it useful for the task. Yeah, and for all the implementation there in practice, we'll be using Python with basic libraries like Torch, Pandas, SQL. Nothing special there. The main work, I would say that 80% of it was regarding the data set. It was the hardest one, right? Because we have to do it manually from scratch. And the biggest thing is there, like without the proper data, nothing will work. So we heavily relied on our data for fine-tuning the classification neural network and fine-tuning the generating network. So it's really important. And there are different kind of techniques. How do we how we can approach of creation data sets, but we decided to go with 50-50 split to make sure that for classification network, we can provide the knowledge of how it's going to be classified the non-functional or functional ones, right? So it was the hardest one because the data set could change a lot. And the thing is that whenever we found out for our approach that data set is not that good, we have to create from scratch, because unfortunately it's much quicker to create from scratch. Yeah. So the most important process there is the tokenization there for like natural language processing approach here. So for BERT is like BERT tokenizer, and GPT-2 is GPT-2 tokenizer. Really nothing special there. For training process, especially fine-tuning one, as I mentioned before, we have been using balanced representation of techniques to make sure the data set is split for equal and functional and non-functional data. And the training itself, we had the possibility to use, how would I say, a much more powerful machine there with Intel Core i9 and 16 gigabytes video memory. So especially with the cores that allows us to train neural networks properly and fast. Yeah, and for optimization, we utilize TenderWheel Optimizer for faster convergence, and classification probability determined using the softmax algorithm. Yeah, so cover up the model evaluation and results analysis. We've been using the confusion matrix there, and those confusion matrices are defined by 4 parameters, I would say. True positives, correctly predicted positive cases; true negatives, correctly predicted negative cases; false positive, false negatives, as it goes, incorrectly predicted positive and negative cases. So there are 2 specific metrics that we decided to focus on. They're pretty much really basic. First of all is precision. the precision by itself focuses on the quality of positive predictions, so we could get there fewer false positives there, while recall focuses up on the quantity of the actual positives identified. The possible why we select those two, because for the use cases, for our requirements, precision is important when the cost of false positive is high. For instance, some sort to make sure our neural network is spam detection ready, I would say. And the recall is really important when the missing a positive case is more costly. Specifically, for instance, it would be medical diagnosis, and for us, it's like functional requirement which could be missed and interpreted wrongly, which is, as I mentioned before, the start presentation could go into really exponential price cost, which is not good. Yeah. Those are the confusion metrics for BERT and GPT-2. The thing is, the most interesting way that bigger number here represents, as for instance, for BERT.
Maxim, you have 2 minutes for finish.
Yeah, sorry. I will. No worries. I was fast enough. Yeah. So different confusion metrics, and it's good to note there they cannot be one-sided. So, for instance, for BERT and GPT, we need to make sure that our models can also have false positives there to make sure it's failure-proof. Because if we, how to say, train those models when our confusion metrics are one-sided, for instance, 500 here and 0 here, it's not that good, because it's the model itself kind of overtrained, which is not good. We also have some accuracy graphs there for GPT-2 and BERT. Of course, regarding accuracy, BERT is better for classification, but that's pretty much it, while GPT-2 has been using for generative content there. And training time is pretty much big for 2 of them, because due to the data set, it takes some time. That's it. So regarding the results, it's pretty much straightforward for functional and non-functional results. And for the case that I want to cover real quick is the hybrid requirements, which, as it goes, contains the functional and non-functional pieces. And for them, our network, how to say, goes a little bit off, and there's some room for improvement to classify them properly. And sometimes they provide like 50-50 split, which is good. And we need to make sure it's more accurate in the future. So that's pretty much it. And the result of the generation, for instance, the first point, well, when the client asks us, the system must allow users to reset their passwords, our generative network provides more expanded description of the system must provide functionality for users and yada yada. So you can see it's pretty much ISO 29148 compliant. So yeah. Conclusions. We managed to create an approach that's pretty much viable, I would say, for our case, for generating the software requirements there. And for neural network, as I mentioned before, for classification, we have been using BERT, and for GPT-2 for generations. Of course, I would say, the result is promising, it wasn't like without challenges and limitations. Our dataset should be expanded, and I would say a little bit tuned, because still it's kind of rough, and it takes a lot of time to create it, which is not really optimal when we change a lot of things, especially with the models there, especially when you want to switch up into manual model architecture type, right? So for the future, we want to expand the dataset, maybe evaluate different models or create our own, and develop a universal questionnaire so we could be used for multitude of different project types there. Yep. So yeah, thank you for your attention. That's kind of it. Thank you.
Thank you, Maxim, for your presentation. Wonderful commentary from your part. Dear colleagues, have you any questions to Maxim? Okay, I have one question. Did you use GPT-2 solely because of its availability, or are there other reasons?
Good question, because we had a really huge amount of different, options there. For instance, the Google T5, like text-to-text transformer, the BART, I believe, by Facebook. But what we have aimed for is the performance and availability for hardware. Unfortunately, not unfortunately, it's the specifics of the neural network that they're really heavily dependent on the hardware. So GPT-2, if we compare it to GPT-3, it has 1,007,000,000 parameters, while GPT-3 has 100 billion, which takes 2 or 3 times longer to train. And because of the reason that our data set changes a lot and pretty much frequently, it's much more easier and much more performative to use previous generation GPT-2, because it's still really greatly pre-trained of the huge amount of the text data. So we decided to focus up on the performance and the possibility of the change of the data set. So we can fine-tune the data set as much as we want without losing much time there. That's pretty much it, I think.
Thank you. And the second questions I have. What is the main distinctions of the proposed approach from the existing ones?
Yeah, our approach is pretty much the combination of different neural network approaches. Here, it's more like an advisor for the business analyst here, and especially we decided to use the already existing standard of ISO 29448 to make sure we can fine-tune or create our model to ourselves that can do this. The difference is that it's still pretty much dependent. How to say, there is no really much approaches for specifically the project requirements there. And we decided to utilize existing standard there to make sure it can advise and adjust those requirements for the business analyst to decide what do with them later. So yeah, that's pretty much it.
Thank you very much, Maxim. Okay. I have not question. Thank you for your presentation.